This video will provide you with activities that will reinforce the concept of subitization. If you're looking for more information regarding subitizing, watch my other video, which focuses on defining the concept of subitization and understanding its importance. Subitizing is the ability to look at a group of objects and determine exactly how many there are without counting. It's a foundational component of number sense. Most students are developmentally prepared for this concept or the concept of subitization around the age of 5. In their learning process, students will build their understanding of number based upon the composition of numbers using visual images and concrete manipulatives such as cubes or other small counters. As learning progresses, these visualizations lead to the building of basic addition and subtraction facts that are based upon the understanding of composition and decomposition of numbers. So how do we reinforce this learning? This video was created to share different activities that will reinforce the concept of subitizing. Activities that are quick and easily repeatable, and very easy to engage students with. So let's take a look and see how these work. So we're going to start with subitizing, and we're going to start looking at just a 10 frame. So the goal here is to just be able to visualize number right now, and that's where our learning progression is our learning progression will begin with visualizing number in magnitude. So included in this video are a series of activity cards that can easily be used, and they're towards the end of the video, and there's also a link that I'll present later on in the video. So here you'll see a 10 frame, and in this 10 frame you see 4 dots. So I'd hold up a card like this in front of a student, and I'll flash that card and say, okay, 1, 2, like quickly flash that card, 1, 2 seconds, and then take it away and ask the student, how many did you see and how do you know? Those 2 questions are key to building that concept of grouping, which is subitizing and visualizing that group. So how many do you see? How do you know? We'll keep repeating those. So a student would say, I'll see 4. And I would say, now it's the important part is how do you know? So now we're proving that that represents the number 4. Student might say, well, I know there's 2 and 2, and that's 4. Or I saw 3 and 1 more. When students are just beginning the understanding or really beginning building this concept, a lot of times you'll see students count, and that's okay. The quicker you flash the card, or the shorter duration you flash the card with, is going to force students to really group. And that's all. This is a whole teaching component there, is to teach the students to group pieces of what they're seeing. So continuing on, here's another card. This card represents 7. Ask the same 2 questions. What do you see? And how do you know? So I see 7. How do you know? Students might say, well, I see 5 and 2 more. This understanding of 5 is building upon that benchmark of 5 and 10, and that's why we're using these 10 frames because it's built upon that understanding the importance of 5. So I see 5 and I see 2 more. Or students might also say, I see 4 and 3 more. There's many different ways that students might be able to grab these groups. It doesn't always have to be that benchmark number. It's the repeated practice of having students really quickly, visually collect groups and then be able to put those 2 together. Random dot patterns. So random dot patterns is different than the 10 frames. The 10 frames provide the structure, and students are used to seeing that structure in those groups of 5, and a 10 frame is composed of those 2 groups of 5. Random dot patterns really forces students to look for those groups. So in the same way, we're going to flash a card like this for 1 to 2 seconds and ask those same questions. How many? How do you know? Again, using the random dot pattern, these are not highly recognizable patterns, so students are being forced to just quickly grab groups. So I would say, looking at this dot pattern, how many are there? And a student might say, well, I see 5. How do you know if there are 5? I saw 3, I saw 2. Or I saw 4 and I saw 1. And it'll be this constant practice. And again, included within this are many other examples of some random dot patterns. So right now we're just talking about building that concept of number, and that numbers are composed of lots of other numbers. Here again is that 5, and on different ways you might see 5. So again, flashing that card, 1 to 2 seconds, pulling it away, have students visualize. Again, when you're working on this and you're just beginning and having students build that concept of number, you might not get the how many do you see. You might not have, student might not be able to tell you 5, but what they probably can tell you are the groups that they see. So a student might start, you can start off by asking a student, what did you see? And we're thinking just in terms of those groups. So I saw 3 and I saw 2, or I saw 4 and I saw 1 more. That understanding will eventually lead to combining of those two groups to find a total. Subitizing using card patterns. So playing cards are an item that lots of us have around the house. Also very engaging to kids, another way just to change it up. Card patterns do have relatable and repeatable patterns in them. So they provide a different experience than both the random patterns and the 10 frames, but it's using the exact same way. So to make these really quickly, just snip off the numbers. The objects on each card represent the number that's on the corner. So I'd flash one of these and I'd ask those same questions. How many? How do you know? When you're just starting, of any of these cards, when you're just starting with students, I recommend using those smaller numbers. So using numbers 3, 4, 5, and keep reinforcing that understanding. 3, 4, 5, just kind of over and over again in different patterns. And again, students might not be able to come up with a total, but they'll be able to come up with the groups. So I see, in this example, we'll look at the red hearts, and we can see quickly that there's 7. How do we know there's 7? Well, I see 5 and 2. And along with like dice patterns, that 5 is a very recognizable pattern. So a lot of kids will say, oh, I see that 5 and I see 2 more. Or some kids might say, oh, I saw 2, 2, 2, and 1. And then they'll need a couple of seconds to figure out how many are there, and that's okay. What we're looking for is the immediate recognition of groups. So they might see those 3 groups of 2 and 1 more. Or if we look over on the black spades, they might quickly see, oh, I see 4 and 4 and 1 more, and determine that's 9, or need some time to determine that's 9. But again, the focus of subitizing is the grasping of groups visually. So now we take the 10 frames. This is part of our learning progression. We've composed number, and now we're going to be using 10 frames and 20 frames to build facts conceptually. And these facts are built conceptually through the composition and decomposition of numbers. So again, we're going back to this 10 frame. So now here I have this 10 frame that represents 4. I'd ask how many there, how do you know? And now we'll take it to the next level. How many more dots do we need to make 10? Another way to ask this, what goes with X to make 10? Let me X represent the 4. Students are now able to subitize the red dots that are there and then look towards the empty spaces. And a student, when you're used to the 10 frame, by this point, they're used to that 10 frame, and they'll see, well, they have 1 more to make 5, and then there's a bottom row of 5. So they'll say, oh, that's, by this point, they'll say, that's 1 and 5 is 6, 4 plus 6 is 10. I can go inversely as well and say, okay, we'll picture this as here's my 10 frame. I have 4 dots. How many are missing? 10 minus 4. I can just focus in on the white spots, and I can say 10 minus 6. Addition and subtraction at the same time using a visual. So this being able to visualize when you're building these facts comes before understanding, or it really comes before understanding fact building abstractly. So let's look at another one. So here we have another 10 frame. How many more are needed to make 10? Just and asking the same question, so a student will quickly subitize. Again, here's a larger number, but they're going to be looking for those benchmarks. So they'll quickly grab and say, all right, there's 5 and 2 more, 5, 6, oh, there's 7 there. How many more do I need for 10? What goes with 7 to make 10? And visually, there it is. They can see that I need 3 more. So 7 and 3 is 10. 3 plus 7 is 10. 10 minus 3 is 7. 10 minus 7 is 3. Jumping up to 20 frames. So once I've really practiced and built that understanding of 10, I transfer that learning to work with 20 frames. Before that, we're going to start with 20 frames. In kindergarten, we start building the understanding of teen numbers. And this is students' first look at place value. So in kindergarten, understanding of a teen numbers are understood as a 10 and then some more. So that's why we have 2 10 frames. This will then lead to the generalization of being able to extend our thinking beyond 10 when it comes time to building math facts. So I would start like I did before, where I'm building number. I'm going to flash a 20 frame and I'm going to ask a student, how many are there? You can't subitize a group of 10, but what you can subitize is a student will quickly say, oh, the 10 frame's full. Right away, in a half a second, they will say, I see 10, and then they subitize the group that comes along with it. So I see 10 and 2 more. And to begin with, when students are first working on this, that counting might happen. That counting might happen as pointing to the dots, or that counting, they're then visualizing, and in their head they say 10, and then you see their fingers start to work 11, 12, and they're showing they see 2 more. So what is 10 composed of? 10 is composed of a 10 and 2 more. Eventually, once students have that understanding of what a teen number is and how it's composed, they then can transfer those understandings that they have from their building of facts within 10 to extend that to work within 20. So now here we have that same 12 again. So I want to know, well, what goes with 12 to make 20? Students have that visual right there. They see the 12, then they see the empty space, and they say, well, I need 3 more to make 5, which is going to be my 15 plus 5 more, which will make 20. Therefore, 12 and 8 is 20 because I got that 8 from that 3 plus their 5. Inversely, we can say, well, we have 20. 20 minus 12 is, and now we're looking again to that blank space. Well, if I have 20 minus 12, there's all the red dots that are subtracted out. What is left? I'm looking to that blank space. Visually, I'm able to see that. So this card represents 12 plus x equals 20. What goes with 12? X plus 12 equals 20. 20 minus 12 and 20 minus something equals 12. The rest of the material here that follows are directions on how to use the cards, along with all the different activity cards. Included within the description of this video, you'll find a link to the PDF of the resources. And these resources can be used or duplicated. So we have 10 frames in various forms that are meant to be activity cards, and these are the cards that we're just using these cards at first. With those young students that are 5 and 6, we're using these cards just to build number. We're composing number. Eventually, this leads to working with facts, which again, these same cards can be used. I have the random pattern cards. Again, this is really for grouping, for visualizing the composition of number. So a student will be able to then say, all right, 7, what is 7 composed of? Oh, 7 is composed of 4 and 3, or 5 and 2, or 1 and 6. 10 frames, just another way of looking at addition subtraction. Now I'm using red and yellow dots. So again, this is students are able to subitize, and we're talking large groups again. However, in the construct of a 10 frame, students are seeing that benchmark of 5 in there. So I can quickly, if I'm looking at the top left card that says that's got 1 red dot and 9 yellows. Again, 9's a large number, not easily subitized. But they're looking at it and saying, oh, okay, I see a 4 and a 5, so therefore I know is 9. 9 and what makes 10? 9 and 1 makes 10. 1 and 9 makes 10. Continue on more 10 frames, and the same follows with the 20 frames. So here we're building teen numbers, understanding teen numbers as 10 and some more, and then transferring those understandings to work with addition and subtraction within 20.